Welcome to yet another exciting educational video brought to you by Upvision Concept Academy. So today we'll be looking at IGCSE Physics, and topic for instruction today is scalars and vectors in motion, displacement, velocity, and speed. So as a way of going through our learning objective, we'll at the end of the lesson be able to explain the difference between scalar and vector quantities using examples from motion. Number 2, define and distinguish between distance and displacement. Number 3, define and calculate speed and velocity and describe how they differ. Number 4, use graph and equations to describe motion. Speed is equal to distance over time and velocity is equal to displacement over time. And finally, but not on the board, we'll solve simple IGCSE style questions involving distance, displacement, speed, and velocity. So sit tight. It promises to be an exciting edition of our lessons. Subscribe if you're going to subscribe to our channel. Share the video so that your friends can be aware of what is going on here, and engage us in the comment section. So we dive in. So what is scalar and vector quantities? So scalar quantities are quantities that have only magnitude, numerical value, only numerical value, and a unit. So it has both numerical value and a unit. So it just have only magnitude. Examples of scalar quantities is speed, distance, mass, time, temperature, energy, and so on. So you agree with me that these are just numerical values with units, just quantities that have magnitude. But vectors, on the other hand, are quantities that have both magnitude and direction. Okay, so quantities that have both magnitude and direction. So examples of vector quantities include velocity, displacement. Again, we have force and acceleration. These are vector quantities because they are defined in terms of magnitude and at the same time direction. So in motion, the difference matters. This difference very matters in motion. If you walk 5 meters north, for instance, if you walk 5 meters north, so this is showing you direction, right? This is displacement. Displacement is 5 meters the north, right? 5 meters north, 5m north. So this is displacement. So, but on the other hand, if you walk 5 meters north, then 5 meters south, your distance is 10 meters and not 0 meters. So if I walk 5 meters north, 5 meters north and 5 meters south, I go north first and I go south. You understand? The total displacement is the total movement from the body as it goes upwards, north 5 meters and down. So you are looking at the summation or the resultant of that movement. It's not as if it is 0, because if you go up and come down, that you did not change position at all. Let's say you started from point A and went up and came up to point A again, then it means that you didn't move at all. Then it means that you are at that point and your displacement is 0. No, it means that you are going to get the resultant of your movement by direction. Direction first of all north, and direction first of all secondly south. So distance is the total part covered, is scalar, right? Distance is the total part covered, So this is scalar, right? Because it just measures, it just describes magnitude, no direction. There's a unit actually. But displacement on the other hand, we are looking at the difference. Displacement on the other hand is the shortest straight line distance from start to finish. So is the shortest straight line distance, shortest straight line distance from start to finish. Okay, so this one has both magnitude and direction. Okay, so imagine example, as a way of example, imagine a student walks 3 meters. Let's say somebody walks, this is a student now walking. He walks 3 meters due east, 3 meters due east, right? So it's going eastwards. Okay, then 4 meters due north. So at this point, this is his direction. At this point, it goes 4 meters due north, 4 meters due north. So the displacement actually, distance actually, difference. Now distance is 3 plus 4 to give me 7. So he walked here and walked here. But the displacement is the resultant. So the resultant. So I will look at the first position of this student, this person, first position, and the last position. So this is second position. Last position is C. So at the end of this movement, the students at A appeared at C. So displacement is the shortest distance between here and here in a straight line. You understand? This one now is the resultant. To get this displacement or resultant, I will say R is equals to square root of that. I'm going to look for the Pythagoras resolution using Pythagoras theory to find this and this. So this and this actually form a Pythagorean triangle, right? So I can get 3 square plus 4 square. Okay, so the displacement or resultant is well, by the time I resolve this, is 5 meters. 5 meters at 53° northeast. At 53° northeast. Okay, how do I get 53 degree? This 53 degree is the angle between that line that connects where you start from and where you ended to the normal. So this is the degree that we are looking for as 53 degree. How did we get this angle? I say theta is equals to the tan inverse of 4/3. This is opposite over adjacent, 4/3. So you get that as the angle, So speed, scalar, is distance over time, formula, distance over time. So this is how fast something moves, regardless of the direction. Why velocity vector is displacement over time. Velocity is displacement over time. That means velocity is how fast something moves in a particular direction. This one is regardless of the direction. This one is a particular direction. So the key difference is that if an object returns to its starting point, average speed is 0. Average speed is 0. This is 0, right? Sorry, again, if an object returns to its starting point, yes, average speed is not 0. Please, because we said this one is regardless of direction. Regardless of direction, right? And this one moves in a particular direction. Okay, so that's the difference, right? So like I said, so the difference now is that if an object returns to its starting point, average speed is not 0. But average velocity is 0 because total displacement is 0. Okay, so if the object moves like this and come back, I have not changed position. That is why displacement, which is 0, will not amount to any change in velocity. But speed is the total distance per time, regardless of direction. So I will have the distance it moves here plus the one is used to turning over time. So that's the difference. Okay, so by way of testing what we just learned about scalar and vector quantities, that is speed and displacement, speed and velocity, we're going to be looking at a question here that will test what we have just learned. So it says a student walks 60-meter knots. Okay, by way of diagram, I will just write it. Let's say this is student position A. So he walks 60-meter knots. 60-meter knots, and that's in 1 minute, yes? And then 80-meter east. So from here again, it moves here, 80-meter east, okay? Also in 1 minute. So this movement from here to here is 1 minute, 60 meters. And from here to here is another 1 minute, 80 meters. Find the total distance covered. Okay, so total distance covered, total distance actually is a scalar quantity, so it does not depend on the direction. Anyhow it goes, I'm going to calculate everything. So total distance is equals to 60 plus 80. That will give me 140 meters. So I'm going to add up, is the summation of the movement. So it moves from A to B to C. So the summation of the distance moved by this guy is the distance covered by covered at AB plus the distance covered at BC. Okay, so total displacement is direction. So it actually moved from here and ended up here. So I don't care how he went to end up here. I will only look for how the shortest distance, straight line, between where he started and where he ended. So I'm looking for AC. So AC is the displacement. So, but I'm going to be regarding this, I'm going to be using what the movements he made to arrive at C to get my AC. So AC, which is displacement, is equals to square root of 60 square plus 80 square. All right? And this displacement also comes with a direction. So by the time I do this, I'll be getting 100 meter. So this is 100 meter. This is the magnitude. But the direction of that movement is, we are going to look for the inverse, the tan inverse of this angle. That is the angle that he moved. The angle. That angle actually is the angle between the resultant line, that line, shortest line between the start point and the end point. The angle between that line, between the start point and the end point, with the first movement where he started moving from. So this is the angle we're looking for. So if this angle, in reference to this angle, I have opposite over adjacent. Opposite over adjacent. So to get this angle, which is the direction, is the tan inverse. Tan inverse of 80 over 60, which will give me 53 degrees. So this guy moved 100 meter, then 53 degree northeast, or east of north, anyone. So I have solved A, this is A, and this is B. Now for C, average velocity. Average velocity is just the distance between average speed, yes. This the speed that comes from comparing distance to time. So total distance covered, average speed is equals to total distance over total time. Total time. Total distance is 140, right? That is regardless of the direction. 140 all over. Total time is 2 minutes, which is 120 seconds. So the average speed is equals to 1.17, by the time you compute this, 1.17 meter seconds, right? Okay, now finally D part says the average velocity, magnitude and direction. Now this average velocity is the one that has to do with direction, you understand? And we are going to be comparing displacement over total time. Displacement already is giving us 100 meters. So average velocity V is equals to displacement over total time. 100 meters is displacement. Total time taken is 120. Okay, so this will give us 0.83 meters per second due east, 53 degree northeast. You see the difference between average speed and average velocity and average speed. See the difference. Same motion, same scenario. I'm getting 1.17 meter seconds for average speed, and I'm getting 0.8 meter per second square, 53 degree northeast for average velocity. So again, average velocity has to do with the change in distance regardless of the direction. Sorry, with direction in consideration. Velocity has to do with change in distance with the direction change in consideration, while speed is change in distance per time regardless of the distance covered. Okay, so we're going to apply what we have learned for circular motion. Again, just apply the concept of average speed and average velocity. So a runner completes one full lap, 400 meters, round a circular track in 80 seconds. So it starts from here, point A, and runs round like this and come here, so and ends here. So it runs round. This is a 400 meter track. If I pull out this circumference to a straight line, it's a 400 meter distance. But it did that 400 meters in 80 seconds. 80 seconds. In 80 seconds. So find the average speed. So now the average speed is distance covered over time taken, right? Now for this distance covered, we're told that one full lap is 400 meters and time is 80 seconds. So by the time I compute this, I'll be getting 5.0 meter per second. Meter per second, right? So that's for average speed. But average velocity, after one lap, let me put this is A, solved. Answer for A. For B, average velocity. Because the guy started from here, and at the end of the day, he appeared here. There's no net displacement from his original position. That means the distance, the displacement this time, the displacement is the net displacement. I'm using the word again, displacement. Displacement means the net movement from the initial point and the final point. You understand? Again, we define it as the shortest distance in a straight line from where it started from and from where it ended. Remember, I defined it that it is the shortest distance from the starting point, from where it started and where it ended. Okay, now look at it again. For this particular situation, I'm seeing that this guy started from here, and at the end of the motion, it ended up here. So there's no displacement. Net displacement for this one is zero. Is 0 over time is still 80 seconds. So if this is 0%, so there's no speed. sorry, there's no average velocity for this particular movement. So average velocity is 0 meter per second. So you see the concept. The concept has to do with the displacement that is attached to velocity and distance covered attached to time, attached to speed. Why distance covered is a scalar, displacement is a vector. In fact, this distance that is a scalar also makes speed a scalar. Why this one, displacement that is a vector, also makes average velocity a vector. So if your displacement does not change, that is your net movement does not change from initial and final to final, then you don't have any displacement, so therefore you don't have average velocity. Okay, so I have a past IGCSE question on the board. It says a boat sails 500 meter east. Direction is east first, then move 300 meter north. Total time of 200 seconds. Okay, so the time that he moved east and north, combine the time together, 200 seconds. Find the total distance traveled. This one is easy because total distance traveled, distance itself is a scalar, right? So it is the total net distance. So total distance traveled is equals to 500 meters plus 300 meters. That will give us 800 meters. So this one is settled out. But displacement has to do with resultant direction. I said displacement. It starts, I will draw it again, I'll draw it here. It starts at a point and sails, let's say this is the point started from point A. It starts at this point and sails 500 meter east. 500 meter east. When it got to this point again, at the end of 500 meter point, that's let's say point B, he now moves 300 meter north. 300 meter north. Okay, so this final point now is the last point he got to. Displacement of this body is actually the shortest distance between where it started from and where it ended at on a straight line. We are not regarding all the maneuvers it made. We are just looking for the change of position. This is where it started from, and this is where it ended. And that position is also defined by a direction. You understand? By a direction. So I'm looking for AC at a particular direction. The direction is the angle that AC makes with the starting point line. Starting point line. Starting point, this is the starting point line. That angle, this is theta, right? So I'm looking for AC. Let me call AC R, and theta is the tan inverse of 300 over 500. The tan inverse of 300 over 500 from your basic trigonometric ratio. Trigonometric ratio and Pythagoras theory. So I'm combining these two mathematical concepts to get Pythagoras theory, to get distance AC and theta angle. So R distance is equals to square root of 500 square plus 300 square. By the time I compute this math, I'm going to be getting 583 meters. Okay, that is for the displacement. But there is an angle. This angle, theta, is tan inverse of 300 over 500. That will give me the angle 31 degree. 31 degree. 31 degree is what? Northeast. See, this line is northeast. Northeast. NE. Okay, so I've gotten B. Now, C says find the average speed. Average speed is tied to total distance. You understand? Average speed is scalar. It's scalar because distance is scalar. So this is total distance 800 divided by 200 seconds. So this is A, I've solved A, this is B being solved. Then C, to solve C, average speed is total distance scalar over time, total time, right? Total time, let me put it like that. Okay, so I have Total distance is 800, right? Total time is 200 seconds. So I'm going to be getting 4 meter per second. Okay, and finally D is my average velocity. That is also a vector coming from combining displacement 500. Velocity is displacement. Please note that displacement is always a vector over total time, right? Total time. Now displacement, we got it as 583 and time is 200. So this will give me, by the time I complete, 2.92 meter per second. So this is the answer for this. This is the answer for this. Okay, so we have practically solved one past IGCSE question physics from what we have just learned. So if you check the marking note for this, correct formulas, if you note the formulas, correct formulas is 1 mark. So I use my correct formula. So when I'm defining this, define the formula that it is the total distance traveled. This one, all the formulas you are defining is 1 mark. If you substitute correctly, is another 1 mark. And if you note your direction correctly, is 1 mark. So you have total of 3 to 4 marks in this kind of question. So I hope this video has been informative for you. I'd like to thank you for viewing.